So today's topic is how immutable is a tuple really? You've probably heard the phrase a tuple is immutable. If you learned about tuples, it's one of the first things you hear about. But there's a bit of an asterisk there. There's a bit of a, well, what do we really mean by this? And this is what this session will explore. Now, this is a summary video of the workshop I've just finished running about half an hour ago. So these workshops go on for about 90 minutes. I will summarize all of that content briefly. So the aim of this video is a summary primarily for those who attended so that they can refresh their memories. I don't record the live session itself, but I do record a summary. Or for those who registered for the workshop and for some reason couldn't make it. So this is going to be brief and concise because it's a summary of the main topic. Okay, so let's start with the key statement. Tuples are immutable. Now, there may be three categories of people who will react differently to that phrase. Some might think, well, actually, I'm not quite sure what tuples are. I'm not quite sure what immutable means, or both. Now, I am going to briefly explain what tuples and what immutable means, but the target for this workshop is a step above that. So if you're unfamiliar with tuples or immutable, I will explain it briefly, but you might want to, before carrying on with the video, read up on tuples and immutability. You can have a look at the Python coding book, the book I've written for beginners, or if you prefer video content, you can have a look at the Python tale, which covers these topics. So that's fine if you're not sure what tuples or what immutable mean. I will explain it briefly in this session. There might be some who think, yeah, of course I know that, Stephen. Tuples are immutable, of course. So what? And if that's your reaction, then this session is for you, because this brings me to the third category, those who think, yes, tuples are immutable, but they can still change in some ways. We need to sort of clarify what we mean by tuples are immutable. The statement is correct. So spoiler alert, there's nothing wrong with that statement. It's how we interpret it. So let's get straight into it. I promised very briefly to tell you what tuples and immutability are. So I'm going to do this super quick. So let's assume we have a list first. Let's say 4, 5, 6. Good. A list is a sequence with items in a specific order, and it's immutable. We'll see what that means in a second. And let's assume I have more numbers, which is a tuple. I'm going to use the parentheses, even though we don't need to use the parentheses to create a tuple. And often when I introduce tuples, I'd say, look, they are a bit like lists. They do very similar things to lists, but one of the most important differences is the following. If I have numbers, and for example, I want to change the second item from numbers, instead of 5, I'm going to make it 999. And lists are mutable, which means they can change. No problems there. But if I try to do the same thing with more numbers, change the first value to something else, Python will say, no, you cannot do that because tuples are immutable. And the documentation says that a tuple being immutable means that its value doesn't change. Okay, we'll dig a bit more on what that means in a bit. So other immutable data types, one of the most common ones is a string. A string also behaves in the same way. Okay, let's now jump to a script. And let me give you the scenario of a real world tuple, if you like. The street I live in. And there are a number of houses. And let's assume that the houses are there forever, right? Where I live, the houses have been here for 100 years at least or more. So let's assume that my street is a tuple of houses. Because the houses, once they're there, they're there. Let's ignore the fact that they can be pulled down and, instead of one house, you can create 2 houses. So let me create a tuple called street. And each house will be a dictionary. So let me put in 3 there. 1, 2, I'll fill these dictionaries in a second, right? 3. And then of course you could have more houses, right? But I'm going to create, not horses, more houses. I'm going to create just 3. Now, it's a tuple because the houses are fixed. And I'm using dictionaries for each house. And for example, here you could have a string with house number, right? They have numbers on the street. And the first one is 1. And the second one, this varies from country to country, right? But where I am, the numbers are odd on one side of the road and even on the other. So the second one would be 3, and the one next to it would be 5. House number is 5. So that could be one key value pair, but I could have more, right? So for example, let me start separating these into different lines to make it neater. So for example, here I could say I could also have a key called residence, and in house number 1 I have the Smiths, for example. And maybe I also have number of residents, so how many people are the Smiths, and let's say that there are 2 of them. I'm going to copy and paste because I'm lazy. House tree, let's assume house tree is mine, right? Because I did say my street after all. So I'll have, let's copy and paste. That's me, the gruppettas, and there are 4 of us, including the 2 kids. Good. And finally, last house. Let's go for house number 5. And once again, let's paste there. Let's say the Joneses, and there are 3 of them, for example. It doesn't really matter, right? Okay, so I've created my street with 3 houses, and each dictionary has some attributes: the house number, the residence, and number of residents. Good. Just as a reminder, print type street. There we go. And that's a tuple. Street is a tuple. You can see there I've used the parentheses and then everything within it. Good, so that's just confirming. And the items within street, I'm taking the first one, but this applies for all of the others, is a dictionary. So we have a tuple of dictionaries. Good. Let's print street. Nothing to see there because it's exactly the same tuple. Now, when we print a tuple of dictionaries or any data structure, you can scroll sideways. That's a bit annoying. So one option is to use the pretty print module. From pprint, you can import, or rather, yeah, from pprint, import pprint, correct. So from the pprint module, import the function which also has the same name. You see this often in Python, right? You have the name of the module is the name of the main function within it. So pretty print does the following. Instead of print, I can use pretty print. And that's much better, right? I can see the tuple of dictionaries in a more sensible way. Okay, now, we've just found out that the Smiths have left. They decided to move somewhere else, move to a different country or whatever. So I want to take this into account. Let's say the Smiths move out. So what I could do is I could say, okay, well, street 0. This is the first dictionary, right? It's the house which until yesterday belonged to the Smiths. So I want to change a few things here. So first of all, I want to say the residents are none. No one has come in yet, right? So the house is vacant for a while. Someone will come in and then we can change it. But at the moment, there is no one. And street 0, so the first house, the number of residents, well, if the Smiths have left, then the number of residents is 0. Okay, let's pretty print street again. And that's the second time it's been printed. And you can see that house number 1 now has 0 residents and residents is none. Good. Except that, wasn't street meant to be a tuple? Well, it is. Street is a tuple. And didn't we say that tuples are immutable? Which means that their value cannot change. But something has changed there. Even though it's a tuple, house number 1 no longer has the Smiths in it, and it no longer has 2 residents in it. There's 0 there. So what is happening here? So let's dive a bit deeper and find out. So instead of printing, let's comment these out, instead of printing street, let me print, before the Smiths move out, the identity of, not of the tuple itself, but of its first dictionary. So I'm going to print the identity of that dictionary. ID, the built-in function ID, gives me a number that's unique to every object. Every individual object in Python has got its own ID number, and that's what ID does. And let me do the same thing afterwards. And when I run these, you notice that the ID number is the same. This means that the dictionary is the same object before and after the Smiths move out. The house analogy is a perfect one here because the house next door is still the same house it was yesterday. What has changed is that the Smiths who were inside it and their furniture and their belongings are no longer there. But the house is still the same one. And that's exactly what's happening here. The tuple contains this dictionary. And what matters is, what is the ID of this dictionary? What object is it? It's this object. Once the Smiths leave, it's still the same object. It's the same dictionary, but its contents have changed. So the tuple hasn't changed because it still contains the same house. It's the contents of the house that have changed. In this case, the Smiths have moved out, the number of residents has moved to 0. And let me convince you of this in a slightly different way. So let's import sys, the system module, and instead of printing the ID now, let me comment that out. I'm going to print from the sys module, I'm going to use get size of, which if you've never used it, you can tell what it's going to do. It's going to get the size of. Now, I want to get the size of street. So remember, street is the tuple that contains 3 dictionaries in this case. And let me copy it and paste it there as well. I don't need ID. So now I'm going to print out the size of street. In fact, I don't need to do it before and after. It's the same value. Let's just do it before. 64. And you might think, so what? 64 bytes, right? This is the size of street. And you might think, is that good? Is that bad? Is it a lot? Is it a little? Okay. Let us, in fact, I could here, just to make it a bit clearer, say size of the tuple street, just to make it clear. Good. And let us print, doesn't matter where I print it actually, before or after the Jones moves. I didn't need this as an F string. I'm so used to doing F strings. This doesn't need to be an F string. Size of one of its dictionaries. And now let's print sys get size of, doesn't matter which one, let's take the first one. Ready? The size of the tuple street is 64 bytes. We didn't know whether this is good or bad, but the size of one of its dictionaries is 184 bytes. And remember, this is just one. There are 3 dictionaries in street. So you don't need to get your calculator out to know that when you take these 3 dictionaries, their size is actually larger than the size of the tuple. How is that possible? And the answer is that the tuple, and this applies to other data structures as well, right? So this is not specific to tuples. A data structure in Python does not store its data. It does not store all the objects it contains within it. Instead, a data structure such as tuple stores references to those objects. So what's happening here? When I create the tuple street, I'm creating an object, a tuple. And this object, well, I am creating a dictionary here, but this dictionary is stored somewhere else in memory. And the tuple street only stores a reference to this dictionary. Again, the analogy I'm using here is perfect, is the address of the house. I can give you a sheet of paper with the address 1 Python Street, or whatever the name of street is. I don't need to give you the whole house, the whole building with all its contents. I can give you the address, and then you can go and find that house and open the door and go in, or whatever you need to do. Same thing is happening here. The tuple street does not need to contain the house. It doesn't need to contain the dictionary. It contains a reference to where that object is. And the same applies for this dictionary. We create a new dictionary, but it's not inside the tuple. This dictionary exists somewhere else, and a reference to it exists in the tuple. That's why the tuple only has 64 bytes, even though each dictionary is 184 bytes, because the dictionaries are not stored within the tuple. The tuple is only storing references to those objects. Of course, the dictionary is doing the same thing, right? The dictionary is also data structure, so it's actually storing references to these objects. But let's stop at the tuple level. Remember, the size of the tuple street, this tuple, is 64 bytes. And to convince you of what we're saying here, let me import sys in a REPL, and let me get the size of, let me create a tuple that contains none, none, and none. It's a tuple with 3 items, but in this case, they're just very lightweight objects. They're the objects, the Python object that refers to none. Clearly, none will take less space than these dictionaries, right? But the size of this tuple is, surprise, surprise, or not really, 64. The same size as street. Why? Because they're both tuples with 3 items. And the reference to an object is the same size whether that object is a relatively lightweight one like none or a larger dictionary. Good. There's plenty more we could say, but I will stop there because I don't want to make the summary too long. So I'll stop with a summary. A data structure, any data structure, but in this case this tuple, does not contain all the objects it stores within it within the data structure. The tuple contains references to those objects. So even though the tuple itself is immutable, so this tuple, in fact let's print out here as well. Print, let's do a list comprehension with the ID of item for item in street. So for each dictionary in street, I'm going to print the ID. And I'm going to do it before and after the Joneses move. And those are the IDs, and if you look at those numbers carefully, they're exactly the same numbers as they are there. This means that the tuple has not changed. The tuple street had a reference to this object, and this object. Once the Joneses left and we have changed what's inside one of those objects, the tuple afterwards is still the same. It's the same tuple with the same reference to the first dictionary, the same reference to the second dictionary, and the same reference to the third dictionary. So tuples are immutable, that is correct. But if they contain immutable objects, these are all dictionaries, then those objects can change, but they are stored somewhere else. The tuple itself hasn't changed. If you have questions, you know where to find me. You'll find me on social media, you'll find wherever you can find me. Just come and ask questions. We'll carry on with this discussion.